Well, I wanted to start out by saying thank you, Michael. Michael Corporal is the CTO of Altius Institute for Biotechnology. Did I get that correctly?
Almost.
Almost.
Biomedicine.
Biomedicine, thank you. And he graciously accepted our offer and asked to come in and share his story and share a little bit about what's going on in the world that he lives in. And then we'll have a few questions at the end, so if you guys have anything specific that you want to ask Michael before we close up, that would be fantastic. Love to have it. Okay, you ready?
Yeah, thank you, and thanks for the invite. So I thought I'd just start off just a couple seconds about me and then what we do at Altius. I've been in software almost 30 years now. I started at Microsoft, and then I moved into the startup world. So I was the technical co-founder of 3 or 4 different companies around Seattle. I quit that about 5 years ago. I was the CEO of a company called Photo Rocket, and as we exited that, the governor asked me to be the CIO for the state, which was a bit of a change from being software development, but for the last 5 years, I did 2 different things at the state, sort of 3 different things at the state. One of them, the most interesting, is I got to be a technology consultant to the governor's cabinet and to the legislature. So issues where technology and public policy overlapped, I ended up being the primary consultant. And that was super fascinating. If you ever get an opportunity for public service, I highly recommend it. It's a great opportunity. That was one of my jobs. The other job is I was the director of the IT organization that was the central IT organization for the executive branch. And then the third job was as the CIO, I was responsible for the oversight, policy, etc. for all of the agency's IT. So that gave me a huge amount of both purview, but also exposure to ranges of problems everywhere from big data to how do we move our COBOL systems out from under our desk. And that was, that was 5 years of fabulous, interesting learning, and it really got me interested in, really in service, in having something where you go to work every day and make a difference in people's lives. So when I exited there, I was looking for something back in the private sector, but in a place where I felt like what we were doing made a difference every day. And that's really where Altius came in. Altius, and it's Altius Institute for Biomedical Sciences. And we are a research institute. We're 100% pure research right now. We're funded partly by the government and partly by a big pharmaceutical company, GSK. But we are, all we produce is academic papers and data. And we work in the area of, and you'll hear me call it about 10 different names because there's a huge swath of both of what people call what we do, but also a broad set of different parts of the market that really cell engineering and gene engineering overlaps with. So in one way, we work in the pharmaceutical industry, but on the other side of that, we work in an emerging industry called synthetic biology. And really, the pharmaceutical industry is, something you all well know. Our main funder is a $140 billion a year multinational company with places everywhere in the world, and research, development, etc. But one of our main collaborators is a lab at UW, and another set of labs at the Hutch, etc. So we work all the way across that giant swath of research, and primarily what we're focused on is computational biology. What is happening inside the nucleus of a cell in particular? So microbiology, and it's generally called computational biology mostly because what we're working with is so small. Every experiment works the same way. You get some tissue, you poke it somehow, and then you see what happens. And there's only two ways to see what happens. One of them is to put that tissue on a genetic sequencer, and when you're done with that, you have on the order of about 80 gigs of raw data that needs to be processed, needs to be aligned to a gene, there's a big pipeline of stuff that happens to that 80 gigs of raw data, and it turns into about 300 or 400 gigs of data on one run off the sequencer. So one way the key thing that we produce is data, and the data comes from two places. One of them is the sequencer, and one of them is a super high-powered microscope. We're also doing a bunch of work trying to understand what's happening in the cell by simply looking at it, staining the cell, taking super high-resolution photos of it, and trying to understand when we poked it, what is happening inside both the nucleus of the cell and the chromatin around that, which is all the fluffy stuff inside of the cell.
That's great. That's really, really good. I am not a biotech person, but every time I talk to Michael, I am fascinated to learn more about the world of synthetic biology. Given that you guys are dealing with the world of data, and that is your main output, and that is how you guys are solving some of these bigger problems, could you bring us back to how Igneous is helping Altius right now?
So, when I first got to Altius, the history of the company in brief is kind of like Brexit, only we crashed out of the UW about 2.5 years ago, and in that crash out, we were well funded, and we had to choose speed over cost or efficiency or anything else, because the breakup happened really fast. The result of that was that the infrastructure that we built is brand new, expensive, on-site, overbuilt, and generally it's managed in a way that only deals with the science and only deals with it in the short term. So when I got there, the net of that is we didn't even have backup. We had about 1.2 petabytes of data, and we have lots of different types of data, but just mostly that stuff that came off of a sequencer or a microscope. We had petabytes of it, and it wasn't backed up. The other thing to know about this type of data is it is literally impossible to reproduce it exactly. You can't take the same tissue culture and resequence it and get the same file. Tissue and biology is not deterministic that way. So if you lose it, it is literally impossible to reproduce it. You can reproduce things close, but if you lose it, it's gone. So running naked on a petabyte of data was not something that the director was excited about, and certainly coming in, you can imagine me coming in from a government to basically a biotech startup and thinking, where do I start? But backup was one of the main things that we started at, and as I looked at conventional backup solutions, they just didn't solve the business problem that we needed to solve, because we have to start with backup, but we also have a much more interesting problem to solve, which, the on-the-ground reality is, how do I get this petabytes of data and share different bits of it with my different collaborators and do it in an efficient way? So when I looked at Igneous, I thought, you're exactly what I need. You're a data router. Anybody who exposes an S3 interface, I'll be able to take that data, as long as I can address it off of my giant storage unit, I can take different pieces of it and route it to different collaborators. And that's a business problem that conventional backup systems never addressed. So when I started to look at your stuff, I thought, okay, not only can I do what I need today, which is, protect this petabyte and a half of data, but I can also follow the vector that Igneous is on into that move data wherever it needs to be kind of problem. And I can tell you that probably the most fundamental problem for synthetic biology, for computational biology, is how do I get my data and my compute to be co-resident so that I can do this massive computation, get my results, but both do it quickly and do it economically. So
Yep.
you need a programmable data router to do that, and that's what you guys are selling right now, and more importantly, the vector of where you're going is right along with what we will do as we go.
Yeah, that's fantastic. We are fortunate to have both the technology underneath our solution as well as the vision to take the technology in these directions. Could you talk a little bit about you needed to solve the backup problem, you needed to solve the data protection problem.
Yeah.
Outside of just that binary, yes, we solved it now, what are the other reasons that starting with data protection for Altius was a good start point?
There's several of them. One of them is both about data protection, but it speaks to another question that one of you asked Kieran earlier, which is how does in particular, the as-a-service part of your pitch resonate? For us, the as-a-service part of the pitch was one of the key things. I only want to put out my people's time if it's moving the body of science forward. Backup, while it's incredibly important, is not moving the body of science forward, and so I want to be able to functionally outsource that. And the as-a-service model is exactly the kind of thing that we're looking at. So it's solving a big business problem.
Yep.
But just on the ground, once you have to quantify exactly what it costs to store something, you get a lot more conscious of what you're keeping and why. So one of the things that just putting the system in place caused us to do is look at how we generate data and what data we need to keep and why we are keeping it and when we reuse it, and to really take a new focus that is the next generation, sort of after the crash out from UW. Okay, you're starting to become a mature organization. How do you start to optimize what you're doing? And your tool set allowed us to be able to do that. And we're at the very beginning of that journey for sure, but that's part of the reason why I'm, as a customer, excited that, I don't have one person managing my data. I got 90 of you. And you're all pushing it in, and I don't know for sure it's exactly the direction that you're going, but from my perspective, you're out talking to my competitors and my collaborators and the other people in my industry, and you're building best practices into your product. What more could I ask for?
Yep. When we were chatting the other day, you had mentioned one of those processes that kind of optimizing and efficiency process game that you guys are getting to, because you're now deciding what you're going to put in backup and what you're going to put in other places, was really around how you want to start organizing the data, not just from a when was it created date perspective, which is very, very understandably the first start. Could you talk a little bit about how you're thinking about the organization of your data now?
Well, again, I have to emphasize that we're at the very beginning of a new process, but really what we're doing today, if you take a step back and look at it, is we're using a file system and file naming as if it were a database. And there's a huge set of problems associated with that, but even if you put a layer on top of that, that you have a better idea of where your data is and how to address it, you still have this legacy of generating data is cheap, regenerating it, or you can't regenerate it exactly, so I'm a little concerned to throw it away. Even if I don't use it, I don't know when I might want to use it, et cetera, so that having the tools to affect that has made us take a step back and say, well, how do we literally organize the data on disk so that the tools that we have can be more effective? So, we pay a lot of attention to your roadmap relative to addressability, for example. Like,
Yeah.
probably the most important thing we can do is having a way, because we're using our file system as a database, being able to describe the pattern of a name and say, I want files that look like that and look like that and look like that, ends up being a critical thing for us, because we generate this much data, and about 2/3 of it is intermediary data that we don't need to keep, but I don't know how to individually address it to get rid of it, and when I can, et cetera. So that's what we look for in your stuff.
Yep, and so now you're being more aware, more thoughtful as data is generated. It is being considered in terms of its life cycle, as
Right.
opposed to just in the near term.
Absolutely.
Is that right? Great. So you mentioned something I think that's interesting, which is the collaboration requirement that you have with other entities in your space. And you also mentioned simultaneously this kind of fissure that's happening, not fissure, but this in the marketplace, the pharmaceutical companies and the what I call the spawning of a bunch
Yeah.
of biotech firms. What I see there is you've got a lot of people trying to do a lot of things with data, and it isn't data that's just held in the four walls of the organization.
Right.
And it's also kind of being made more complicated because of the outcropping of new organizations that's coming out of pharmaceuticals into these biotech firms. When you think of those two forces happening, right, how do you think Igneous is poised to really kind of solve some of those issues in what you call synthetic biology, which I've heard as well? And what are the, outside of the scalability and the ability to handle file data and all of that, what do you think we should be focused on and thinking about in terms of solving some of those issues?
It's a good question. The structure of the industry is really interesting right now because, and this has been true historically in the pharmaceutical industry, these massive, $180 billion a year companies sort of grow out, and they're really structurally not capable of a huge amount of innovation. And so one of the things that they do is that to be able to innovate, they pick specific problems, and then they take a team and they literally spin them out, fund them separately, et cetera, but they kind of unshackle them from the bureaucracy that's required to be able to run a multinational company. And we are in the process, we're at a stage right now where that sort of freeing of both some of the researchers inside big companies and a lot of the executives is happening all over the place. Seattle is actually a huge mecca for that. Seattle is attracting a bunch of big pharma. Novartis is moving in here, Bluebird is moving in here, GSK opened basically us. And the reason that they're doing it is because, we have one of the best research institutions on the globe, and all of the things that the UW has spun out, the Hutch, the Institute for Systems Biology, et cetera. So we have a big research organization around here. But we also have a bunch of computer scientists, and a bunch of chemists, and a bunch of physicists, which is what it takes to do synthetic biology. So what you're getting is this continuum in the market where you've got big pharma on one side, and big pharma is giving executives and dollars and IP to the synthetic biology market on the other side, which is a bunch of startups. Now these bunch of startups are a little bit different from a high-tech startup for a variety of reasons, but probably the most important one is to start one of these companies as Series A is an $80 million initial raise. It's really expensive to do synthetic biology because most of what you're doing is discovery, and mostly what you discovered is the thing you tried didn't work. So, that continuum is reflected in David Baker's lab out of the UW. David has started 8 different companies that are all about how you do protein folding and how protein becomes medicine. And each one of those are sort of kind of moving up the scale until you hit companies like Juno that sold to one of these things for $9 billion last year without actually having a product in the market. So all along that continuum, different stages of companies, et cetera, they all have a consistent problem that you have the opportunity to address, which is fundamentally, they produce the same thing that we produce, data. Every experiment is the same thing. You take some cells, you poke them, you find out what happens, and the only way you find out what happens inside the nucleus of a cell is to analyze the data. So that, down here in the synthetic biology, what you have is a bunch of people in hard sciences that are doing everything, including building what they call biological machines, to do like real world stuff. This is, they're building proteins that eat oil. They're building, there's a startup in Seattle that helps brew beer better, because basically protein generation is the same thing as growing yeast. So they make synthetic proteins to make beer taste different. There's also a group in Boston that is doing cell engineering to actually make it so you can make beer without using hops. They've changed the way that the yeast and the wheat work to make it taste like hops. And the reason that I picked that is there are two forces that, in my view, actually drive whether or not an industry is going to be around for a long time. One of them is, does it affect a lot of people? And I liken this to the internet. Does it affect a lot of people, and is there a lot of capital in it to drive the staying power of that area? Synthetic biology touches everything that's alive. Everything that is alive, from medicine to brewing to actually creating synthetic alive things, which is really the ultimate goal. So it affects everybody. And the explosion of the ability to support synthetic biology with computation, with that data, is the thing that's enabling a giant market that's never going to go away, because the amount of dollars that are driving it is just so huge. The pharmaceutical companies are some of the biggest companies in the world, and the opportunity to make a new drug, the value of that, they can't afford not to be investing in that. So that entire continuum from tiny little startups to Juno to GSK really is your, I mean, at least in health sciences, like from our view, that's a huge market for you, because everybody there has that same problem. How do I capture and manage and analyze and visualize and protect and move around the data?
So from your perspective, the way we talk about unstructured data management, of being able to see it, organize it, protect it, move it, doing so in kind of an automated fashion, that lines up with what you're saying is core to some of these issues around the physics problem of data. Is that right?
Absolutely. Yeah, although the one thing I'd say, particularly in the life sciences world, they don't think about it as unstructured data. Only the IT geeks like me think about it as unstructured data. It's just data. And they don't really make the difference. They're not conscious of the difference between data that came off the sequencer and all of the metadata that lives in a database that described what happened to the tissue while you were poking it. It's just data to them.
Yep. That's a good insight. That's a really good insight. Yes, the focus on unstructured versus structured, and those that care is always an interesting conversation.
Yeah.
So physics issue of keeping data close to compute. Any other top issues we should be thinking about and aware of that you think are kind of right on the horizon in the world of data management and the world of Igneous?
I think probably my experience in government suggests that one of the biggest issues around data is going to be around data governance and data ownership. you can imagine you have 40 agencies inside government that all feel like they have generated data and it's theirs and they don't want anybody else to look at it, et cetera. And that's ignoring all the regulations about who can see what, et cetera, et cetera. But that set of problems that is so acute inside government happens on this end of the market all the time, in the big companies. When I talk to people at GSK, they say their biggest internal problems is silos. And they're talking about science, but largely they're talking about data. And they have just created a data lake that's centralized. Their vision was to centralize all the data in GSK so it could be manipulated. They have literally 1 million individual streams that are coming into their data center. And it's everything from unstructured data to database backups to, so the complexity of their problem is enormous. But even once they got it generated, who gets to look at it, and how you deal with the regulation around it, how you deal with, in their case, HIPAA issues and PII and all that sort of hierarchy of the first grade, it's my data, I own it, to I need to, it's HIPAA regulated and I have to care about you've got to care about data ownership and data governance, everything in between. I would argue that is the next major issue on the horizon. And if you look at, certainly in the market of states, you can see a reflection of that in the rise of a whole new title, the Chief Data Officer. There are now 7 Chief Data Officers of a state, which is, that need to do data governance is actually rising just as fast as probably the other issue, which is privacy. Privacy for a policy issue is a completely different sort of thing, but data privacy in general, and I'm not talking about cybersecurity. That's a different issue. But data privacy and being able to scrub data, know where your data is, make sure that the right people can view it, etc. Those are the big drivers of the people outside the IT organizations as they look at their data assets.
Yeah. So the business, the organizational leaders, that's what they're focused on, and that increasing pressure is already occurring, has been occurring. You foresee that only increasing.
Absolutely.
Great. That's
Data
awesome.
is the currency that big companies, certainly the government will use, and big companies, particularly in the space you're talking about. You just can't make decisions. You can't make, treatment decisions. You can't make research decisions without that huge bolus of data. So who owns it and how you control it, absolutely key.
Great, good. We have 2 more minutes. I'd love to open it up for additional questions. Eric, do you want to go first?
I have a ton of questions. I don't know how to choose.
Maybe we'll take an extra 2 so we can make it 5 minutes. Okay, we can take some extra time.
So, Michael, good to meet you. I cover Boston, so I'm talking to a lot of folks in your space.
I'll bet.
It's sort of a 2-part question. How do you kind of message how do you message your service to these pharma companies, and what is the value to the business that you're seeing with these types of technologies? Is the time to discover drugs shrinking? Is the investment to discover drugs shrinking? And what is the compelling reason for somebody to come to you because you guys have a better service to do research for them?
So I'm going to repeat the question simply, or if you want to repeat the question, we
sure.
just want to get it on the camera. Yeah.
But I think I'll simplify the question and you tell
Sure,
me if I got it
please
right,
do.
which is, what's really the compelling value proposition for Altius to a pharmaceutical company?
Yes.
And really there are two categories of that. One of them is a pharmaceutical company that wants to make what they call small molecule drugs. A single pill that can be used across, that can make millions or tens of millions of people better.
Right.
The other, which is a very different market, different process, different everything, the other is when you're actually you're using the biology to make a treatment. So when you are making aspirin, the value that we provide is we can actually, if you say, all right, we have this compound that we think is going to affect the tissue, the gene, whatever, in a particular way, we can actually engineer that tissue to have the malady that you want to see if you can fix it.
Right.
That's a really, really hard thing to do.
And so is that improving on the existing chemistry, or is
Yes.
that creating new chemistry as well?
It's creating, what we do doesn't create the new chemistry, it creates a use for the new chemistry.
Okay.
Right?
All right.
And so that's if you're trying to build a drug that is fundamentally a small molecule drug, where chemistry is the drug itself. The other way is where biology is the drug itself. And for that, what we're doing is we focus particularly on cancer, and we do research particularly in the area of how proteins are expressed on a cell that allow your immune system to be able to either attach to the cell and kill the cancer, or how we can disempower the proteins that are hiding the cancer from your body, right? So either attach it or unhide it, but basically change the makeup of your cancer so that your body can fight itself. People talk about that as immunotherapy, and so we're doing the fundamental research that allows that to happen. So if you are, just in the last 3 months, there are 2 different companies that have spun out of what remains of Juno, and both of them are in that market. They are trying to create cell and gene therapies that pick a specific malady and try and cure it. And we would end up supporting an organization like that to actually build specific molecules that they would use to build their therapies.
So a quick follow-up is, what is the business impact of you guys doing it versus them? Are you seeing is the technology a big driver for that business impact? The savings, the efficiency, the time to market?
Yeah. The question is really how does the technology and the economics kind of overlap, particularly relative to the big companies. Relative to the small companies, the technology is the thing, right? I mean, that is what you're building. You're building the technology that creates those molecules that gets turned into a therapy. So the technology is everything. Relative to the big corporations that aren't trying to build cell and gene therapies, they're trying to build small molecule therapies. Basically, what we do is really on the cutting edge, particularly on the cutting edge of gene editing. But to the extent that we can generate a target that they can test different compounds against, that can shorten the drug process. From start to finish is generally about 10 years. They estimate that if we can solve that one problem, and there's actually 2 problems we solve there, but that one problem can shorten it almost 3 years. So it's moving from a multi-billion-dollar process to smaller numbers of billions. So the economics of it are hard to ignore.
Thank you.
Yeah. Please.
Thank you. This has been extremely educational to me. I appreciate your time coming in today. I'm actually down in San Diego.
So you
I know
live in this
so-
market too.
I tried to take some good notes here. So I'm curious about the raw data and then the sequencing, the small to large data. Right? So, and the not exactly recreation piece. How did you sell that internally from a budget standpoint? Because we've actually worked with other farmers, other companies similar that we're just going to recreate the data. So I'm kind of curious, how that discussion was internally to get, the X hundreds of thousands of dollars, whatever it was you paid for.
Well, you guys are so cheap, it was an easy
We call that value add.
I think the delta there, really the question was, how do you balance in particular in terms of cost, generating the data and storing it versus generating the raw data and not worrying about, and then knowing that you can recreate all the analysis downstream. Both of those strategies are employed in the market, and they're both perfectly reasonable. The big difference from us and why we feel as a general rule that we need to be able to keep the exact data and secure it is because in addition to the data itself, what we generate is papers. And when you put a paper out into the scientific community, the whole point of it is somebody else can recreate it, they can validate your assertions, they can look at your paper. And to do that, you need the exact data. So, it often, like in the research, in the process of research, often what a researcher will do is regenerate, like we have a whole pipeline that takes a tissue sample and then generates, about 80 gigs of data from that original file that has a bunch of different analysis. But that pipeline changes all the time as we have new QC metrics, as we modify, find smarter ways to do it. And because the pipeline changes, it won't generate the exact same data. So when you're in the research process, you just regenerate the data all the time because you assume the pipeline now is better than it was before. But if you're in the paper publishing process, you got to put the data, you got to have it solid and publish it out where it's immutable. Otherwise, people won't be able to recreate it.
David, and then we'll get to you, Anthony.
So you alluded to having to quantify the value of that data back to the business. Can you give us some insight as to what that looks like? Are there certain key metrics so you're quantifying that data, the service you're providing, and of course how Igneous is providing, and what those kind of metrics might look like back to the business?
Unfortunately, I can't beyond the obvious, storage per terabyte. And the reason that we haven't even tried is because there's no way to quantify the value of data that is not reproducible. I just don't even know how to do that. I know how to quantify the cost, but I don't know how to quantify the value. And the cost is fairly obvious, right? I mean, the cost is you take the amount of data that you have and you multiply it by divide it by the amount of money that you're spending, and you can. So that particular metric, because the data itself can't be recreated, or it can be, and the cost is just computational, depending on the need, as we just talked about. The net is that we unfortunately we haven't quantified it in that way. What we have done is say, look, now we know what the cost is, and even if it's really, really cheap, if we can quantify the cost, and you're never going to use the data again, it may be worth the effort not to keep it. But we don't have hard and fast metrics on that yet because we're just at the beginning of that process.
And in your evaluation, though, I think I recall you talking about quantifying the comparison of cost between the Igneous solution and others in the marketplace. Can you share a little bit about how you did that and what that netted out with?
Basically what we did was look at on-site choices.
Yep.
And try to do a fairly straightforward total cost of ownership. What we found is that while the software and the storage and all the physical technology, first of all, it was expensive, but more importantly, the ongoing OpEx cost of basically having to hire a human being to keep your backup, like that, when you looked at the TCO over a sufficiently long amount of time, it's just a no-brainer that just on the economic basis, storage as a service made much, much more sense. But the bigger driver goes to the point I made before, which is I don't want a company of multiple thousands of people. I want a company that is focused on the thing that we are laser focused on, which is moving the body of science forward. So I don't want to have full-time employees that are doing that. I want to hire you 90 people to do all of that and keep it moving, because while it's critical, it doesn't move the body of science forward, and that's the litmus test that not only we use, but you know, anybody that kind of looks like us, at least in my view, should have that same perspective. You know, that, yeah.
Anthony has a question, sorry.
Rob, I got one over here.
Okay.
Yeah, you mentioned at one point, yeah, hey, we're just dumping files on file systems when maybe we wish we had a structured database kind of schema going on here, or who knows what. At the same time, that seems to be the way things continue going. So I guess basically, in your view, what makes it so that you just kind of leave that untouched at the source of data generation? We're going to continue to just throw lots of data on a file system, and we're going to use other tools to try to handle making sense of it later, versus trying to put something in at the source of the generation that is doing more to structure that data.
So the question is really, how do you balance and kind of where in the pipeline do you put the intelligence to do smart things with your data, to organize it in specific ways? Or the kinds of smart things that we would be doing would be, like today, what we do, the way we organize our data on disk, is everything that comes off of the sequencer gets put, it's not this simple, but basically in the same directory. So we organize it by date the data was generated. And only within that do we, because the sequencer doesn't do one tissue sample at a time, it might do hundreds. And so all of that data is sort of commingled. And the only way that we can keep track of it is because we know exactly what was on the sequencer, and the database manages all of that. But a smarter way to do it would be to build intelligence into the pipeline so that we can distinguish and put different data that performs different functions, organize them together on disk, and that will allow us to use your tool set much, much better. Today, we don't have the ability yet to be able to distinguish data that we want to keep and that's really granularly important from those intermediary results and duplicate data and a bunch of other stuff. So because the level of granularity we have is a directory structure. But the long-term solution to that is to build it into the pipeline that generates all this data and have it put in different places. Today our pipelines don't do that, but tomorrow they will. Today our pipelines are just data generation machines. They don't do any organization.
Yeah, it seems like one getting better lets you use the downstream tools better that will mesh together.
Yeah.
Thanks.
So, Michael, I want to say thank you, number one. This has been amazing. I know there's other questions, but I also know that Michael's got to head out. So, are you open so that we can kind of convene this session? Are you open to a few more minutes? Maybe, I know Eric's got
Sure.
some questions for you after this, and we're going to be getting ready to head out to our team event, right, Anna? No. We've got Karan. Okay, great. Did you want to keep this open, or should we wrap up?
No, we should move on to the next stage.
Yeah. All right. Fantastic. Okay, you guys, can you say thank you to Michael?
Thank you.